Okay, here we have few variables, that is dummy variables, GDP, investment, and finally the rate of literacy. So we have four variables and I am opening all the variables as a group. So this is my all the variables you can see. So the first one is dummy, GDP, investment, and literacy. And the data start from 1980 until 2010. That is our data from 1980 until 2010. And we have four variables: the dummy, excuse me, GDP, investment, and the rate of literacy. Okay, these data I have taken from a country like Maria Land. So actually Maria Land is a hypothetical country. Okay, from there I have collected data, and but here I have put one variable which is dummy. You can see from here, from the 1980 until 1999, the dummy I have taken all zero. Dummy I have taken 0 from 1980 until 1999. But from the year 2000 until 2010, the dummy variable is 1 that I have chosen. So what does mean by 0 and what does mean by 1? Okay, from 1980 until 1999, Maria Land was not a welfare state. From 1980 until 1999, Maria Land was not a welfare state. So the country was not a welfare state, which is 0. What does mean by 0? Dummy variable, meaning that the country is not a welfare state. That is all 0. Okay, but after 2000, Maria Land become welfare state country. That means Maria Land convert into welfare state by constitutions, and that start from 2000 until 2010. And here I have put all 1. You can see 1. 1 means welfare state here. So I am telling again, 0 means not welfare state and 1 means welfare state. Okay, and what is our objective of this model? The objective is that welfare state that Maria Land has become has a positive impact on the literacy rate of Maria Land. I'm telling again our objective. The objective is that welfare state that Maria land has become has a positive impact on the rate of literacy of Maria land. That we want to check. That we want to check whether welfare state has a positive impact on the rate of literacy or not. That is the objective. And if the dummy variable become significant and the coefficient of dummy variable become positive, then only we can say that welfare state, which is Maria land, has a positive impact on the rate of literacy. I am telling again, if our dummy variable becomes significant and if the coefficient of dummy variable become positive, meaning that welfare state has a positive impact on the rate of literacy of Maria land. Okay, and here actually we shall develop, our target is to develop error correction model gradually. But first we develop the unit root testing. That means whether our GDP, investment and literacy, whether these three variables have unit root or not. That we want to check. Okay, but here we have no plan to check it. We have no plan to check it. We just assume that the GDP, investment and literacy, these three variables become stationary after first difference. That means at a level they are non-stationary. But when I convert this variable into first difference, they become stationary. That we just assume, right? And when this thing happen, only then we can run the Johansen cointegration test. So I'm telling, when we can run Johansen cointegration test, we can run the Johansen test of cointegration when the variables are integrated in the same order. Only then we can run Johansen test of cointegrations. And here we have assumed that all the three variables become stationary after first difference. So they are integrated of the same order. So now we can run the Johansen test of cointegration. How to run? I go to quick, then group statistics, then Johansen cointegration test, right? I choose from here. Okay, so first I write literacy, then I write GDP, then I write investment, these three variables. But these three variables are non-stationary right now. That we assume that these three variables are non-stationary right now, but if I convert them into first difference, they will become stationary. Okay, then I run the model, the Johansen model, and here I choose 3, and lag I choose suppose 4. I choose 4, right? 4 lags. Then I run the model. Okay. So this is the outcome. Literacy, investment, right? And here our trace statistics, right? And also my max IGN statistics. So first we check this one, trace statistics, right? Okay. And it is our null hypothesis, number of cointegrated equation. Okay, suppose the null hypothesis is none. None means there is no cointegrating equation. So can I reject this null hypothesis? Yes, because the p-value is less than 5%. How much is the p-value? 0.43%, which is less than 5%. So when the p-value is less than 5%, we can reject null hypothesis. Okay. And also we can check here, you can see that trace statistics is more than critical value. So what is the guideline? The guideline is that if the test statistics is more than critical value, we normally reject null hypothesis. And here 38.16 is bigger than 29.79%. So we can reject null hypothesis, which is this one. Okay, then what about this null hypothesis? At most one cointegrated equation. Can I reject this one? No. Why? The p-value is 29.86%, which is more than 5%. So we cannot reject our null hypothesis. And what is the null hypothesis? The null hypothesis is there is at most one cointegrated equation. And also we can see from here that trace statistics 9.777 is smaller than critical value 15.94. So we also cannot reject null hypothesis, meaning that we accept null hypothesis. And what is it? There is at most one cointegrated equations. And you can see from here the decision. Trace test indicates one cointegrated equation at 5% level. Why 5%? It is from here, critical value, right? At 5% level. Okay, then we talk about max IGN statistics. So this one is the another statistics. And what is our null hypothesis? There is no cointegrated equation. Can I reject? Yes, because the p-value is less than 5%. so we can reject null hypothesis. And also from here, the max eigenstatistics is bigger than critical value, so we can also reject null hypothesis. Then what about this one? Second one, the null hypothesis is there is at most one cointegrated equation. Can I reject it? No, because the p-value is 22.75%, which is more than 5%. So we cannot reject null hypothesis, meaning that there is at most one cointegrated equations. And we can also see from here, you can see max eigenstatistics is less than critical value. So what is the guideline? The guideline is when the test statistics is smaller than critical value, we cannot reject null hypothesis. Rather, we accept null hypothesis. So, what is the decision? Max eigenvalue test indicates one cointegrated equation at 5% level. So, both the test statistics and max eigenstatistics is telling that there is one cointegrated equation. What does it mean? It means that our three variables such as the investment, GDP, and the rate of literacy are cointegrated, or our three variables have long run associationship. Okay, so and when the variables are cointegrated, then we can run the VECM model. So what is the guideline? If the variables are cointegrated, we can easily run vector error correction model, and that we shall do now after a while. Okay, so our three variables are cointegrated, so we can easily run the vector error correction model, and that we shall do now. So I go to quick estimate var, then I write the variables. So the first one will be the literature, because that is our dependent variable, literature, and then GDP, then investment, right? And here I choose vector error correction model, and exogenous is our dummy variable, right? And here what is our target? Our target, whether the dummy variable has a positive impact on the literature or not. That we want to check today. That means whether welfare state has a positive impact on the rate of literature or not. That we want to check today. And we have chosen here, we have chosen lag 1 because our target is to develop an error correction model. So I choose lag 1. You see, I have chosen lag 1, right? I have chosen lag 1, and yes, everything all right. Setting is all right. Now I check cointegration, right? I check here. Okay, and how many cointegration? Last time we saw one cointegration. Last time in the Johansen test of cointegration, we saw there are one cointegrating equation. So here I write 1. Actually 1 is already given there, so I do not need to write 1 because it is already given. Then I choose number 3, right? Okay, then I run the model. Oh, sorry. Later, I think I have done a, okay, I run it again. I think I have done some mistake here. Oh, sorry, it is not literature. I run again. Estimate var vector should be literacy, not literature. Literacy, GDP, investment, right? So these are the 3 endogenous variable. And number of lags, suppose I choose 1 lag, and exogenous is our dummy variable. Literacy, yes, we can check from here, literacy. So I put the literacy first because the literacy will be dependent variable. So, and I choose vector error correction model and cointegration. I choose 1, right, because we got 1, and I choose 3, right. Then I run the vector error correction model. Yes, this is my vector error correction model, and you can see the cointegration equation. Here the dependent variable is literacy, and this one is the cointegrated equation, and this is the error correction model, right, having lag 1, right. Okay, this one is the coefficient, this one is the standard error, this one is the t-value, but here is no p-value. You can see there is no p-value. Also here it is coefficient, it is standard error, and it is t-value. But my target is to know the p-value. So how to know the p-value? So I go to edit, I go to proc, I go to make system, and I go to order by variable, right. So well, we can see our 3 model. That is the model number 1, and it is model number 2, and it is the model number 3, right. So we call it system model, system equation. You see it starts from C1 until C18, right. And here from here to here, actually from here to here until this, actually we call it cointegrated equation, right? And what we shall do, we shall be taking residual from here. We shall be taking residual from here, and that will be used as a error correction term. We take the residual from this equation, and that will be used as a error correction term. Okay, so we need this one. We need only this one. So I take it, I copy, and I go to quick. Then I choose estimate equation. Then I paste it. I paste the whole things here, right? So I press OK. So this is my error correction model, where literacy is the dependent variable. You know, the VECM model automatically make the variable into first difference all the time. You see, last time we put the only the literacy, but VECM model converted it into first difference. You can see from here there is a D, right? First difference they have converted. Why? Because when it becomes first difference, the data will be stationary, and that is why they convert it to first difference to make the data stationary. Because normally time series model need stationary data. Okay, this is our model, error correction model, and this is the dependent variable, and C1 is the coefficient of the error correction term, right? You can see from here, right, from here to here until this C2, C1, which is this one, right? C1 means this one and this one. So this one is the error correction term. And what is C2? And C2 is this one. You can see from here. C2 is the actually this one, the coefficient of the literacy. And C6 is the coefficient of dummy variable, right? That is C6. Okay. And okay, now we check one by one. C1, the error correction term is significant. You can see from here, significant, and the coefficient is negative, right? There are two things are here. One is the error term is significant plus negative. It means that that there is a validity of the long run associationship among all the variables, right? So I'm telling again, when the error correction term is significant and negative, it means that there is a validity of long run equilibrium associationship among the variables. So we are happy that all the variables have long run associationship because error correction term is significant and negative. What about C3? What is C3? C3 is the GDP, right? This one. C3, is it significant? No. That means GDP does not influence the rate of uh, literacy. C4, C4 is not also significant. You can see from here. So, but C5 is the intercept, but the dummy variable is significant. You can see significant. Why? Because the p-value is 3.94% and the dummy variable, the coefficient is positive. So if the dummy variable is significant and if the coefficient is positive, it means that welfare state, which is Maria land, has a positive impact on the on the on the rate of literacy rate of literacy in Maria land. I am telling again, if the coefficient is positive and it is already positive, and if it is significant and it is already significant, meaning that the welfare state that Maria has entered has a positive impact on the rate of literacy, meaning that that means the Maria land has taken the right policy by converting the country into welfare state. As a result, it can contribute to the rate of literacy in the Maria land. Okay, now we shall check how is the model as a whole. That means how is this error correction model statistically, how is it? Okay, one thing, first I start with the R square. R square is 47.54%. So that is low, that is not high, so that is low. That is the problem of this model, that the data is not nicely fitted. So this model has this problem. And another problem, that C3, which is GDP, and C4, which is investment, both the independent variable are not significant to explain the dependent variable, which is the literacy. So that is also a bad sign of this model, that two variables are insignificant, right? So, but the good sign is F statistics is significant. You can see the probability value is less than 5%, meaning that independent variables jointly can influence the dependent variable, which is called literacy. And here what is happening, you see C2, C3, C4, they are not significant individually. Individually they are not significant, but jointly they are significant. Why? Because the F statistics is significant. Actually, what is the F statistics? F statistics actually talking about joint significance of the independent variables on dependent variable. And when the p-value is less than 5%, then we say that independent variables jointly can influence the dependent variable, and that is desirable, and that should have for a good regression model. So uh, so so we are happy about the F statistics. Okay, then we talk about residual, whether the residual of this model, right, whether it has any arch effect and so on. Okay, first I check one by one. I go to view, I go to residual diagnostic. Then first I choose the serial correlation, whether the residual of this model has serial correlation or not. That we check first. Okay, suppose I choose lag 2. Okay, so this one is the Bruce-Godfrey test, LM test, and observed R square and corresponding p-value. What is the p-value? 18.15%, meaning that more than 5%. So we cannot reject null hypothesis. And what is our null hypothesis? The null hypothesis is there is no serial correlation, which we cannot reject. So that is desirable, and that is a good sign of this model, that there is no serial correlation. So we are happy about it. Okay, then I check again. I check, suppose this time I check the heteroscedasticity test, right? This one I check. Okay, here are many tests. Suppose I choose the arch effect, whether this model has any arch effect or not, right? That we can check whether there is a arch effect. So suppose I take number of lags 2 lags I choose, right? So then I run the model. It is the arch model, observed R square, and the p-value 94.05%, which is more than 5%. So we cannot reject null hypothesis. And what is the null hypothesis? The null hypothesis is there is no arch effect, and we cannot reject it. And that is a good sign for this model. We are happy about it. Then I talk about other test of residual, which is test of normality, histogram, right? I want to check this one. Okay, Jarkabera statistics and corresponding p-value. How much is the p-value? Less than 5%, meaning that we can reject null hypothesis because the p-value is less than 5%. And what is our null hypothesis? The null hypothesis is the residuals are normally distributed, which is desirable. And what is alternative hypothesis? Residuals are not normally distributed. So here we can reject null hypothesis meaning that we accept alternative hypothesis, that is residuals are not normally distributed. So that is a bad sign for this model, that residuals are not normal. So that is a bad sign. But still it is manageable, because even the residuals are not normal, still we can accept the model, right? Still we can accept the model. No, normally yes. Actually, there are many people are supporting the statement. Many econometricians are supporting the statement that although the residuals are not normal, still it is manageable.